And the winners will have an opportunity to win Echo Dot. So do participate. Also, Ilachi is recruiting Alexa developers. Do not miss this opportunity. Up next we have Mani Chandrasekaran. Mani is a senior solutions architect at AWS, based in Bangalore, and works with customers in their journey to cloud. He has worked for more than 24 years in the IT industry in India and the USA. He is one of the few technologists in the world who completed all the 11 AWS certifications, including the AWS Certified Alexa Skill Builder specialty, and is also certified Kubernetes application developer. He is passionate about technologies and is active on Twitter and LinkedIn. In the past, he has worked with EMC, Actin, HP, and IBM.
They have come up in Alexa, right? Now, that's from the Alexa side, right? So, now, as you develop skills, obviously you got to write in your own skills, right? How do you fulfill them? So, there are, how many of you have actually developed skills which used like a web service or Lambda? Good, right? Good. So, I'm a solution architect with AWS. So, primarily I'm going to talk, this is going to be a technical talk, right? So, I'll be talking about, there is one aspect where you get something like a small application out of the box, but then what happens if your skill becomes popular and a lot of millions of users start using it? You got to think about that part. So that's where I think some of the tips that I'm going to give you will be more from, that will cover a lot of aspects around what are the new features of Lambda that you can use, and how best to improve it. So things might not be very apparent at first, but these slides are available. You could always, as you develop your skills using Lambda, you could refer back to these slides so that you make the user experience better, right? Isn't it? So I mean, you develop a skill, and of course, when you deploy it using the Alexa developer console, you obviously have two choices. One is you could use a web service, or you could use AWS Lambda to fulfill your stuff, right? And obviously, web service is something that outside the realm of this discussion. But there is a very tight integration with Lambda, right? So that's where, for example, a lot of these real-world use cases, right? I think a lot of companies use, individual developers use it, where you need to do some real-world stuff. It's got to talk to your database, it's got to talk to a third-party, web service and things like that. So that's where Lambda comes into picture. So Lambda, AWS introduced Lambda more than 5 years back. So obviously, for a lot of other vendors, it could be day one. For us, it's almost been 5 years. So that means it's a very mature technology, and a lot of things that we are doing is obviously to enhance performance and things like that, where we have seen people using it, right? So what is Lambda? So essentially, Lambda is a serverless kind of compute platform. Some folks also refer to it as a function as a service. I mean, we don't. But it's a serverless platform where essentially these are the few pieces to it, right? So there is this compute kind of a thing where obviously we talk about serverless, but it's got to run somewhere, right? So, but obviously the compute is kind of invisible to you as a developer. It's something AWS responsibility. And then there is a Lambda service itself, it runs on top of this compute. And then from the execution environment, language, runtime, and function, the first three are something that you control. Okay, and so far, if you had to do some tweaking, pretty much the first two and maybe a little bit of the third was where you had some control. But I will talk about the fourth part of it, where you would also have some additional enhancements where you could control performance. Coming back to the function part of it. As of today, we support 6 mainstream languages, right? But we also introduced something called bring your own runtime. So if you have your own favorite language like PHP, you could always do that. But you got to ensure that the language of choice that you select for writing your skill should be obviously modern and supported and things like that. Because Lambda as such, which I talked there, there are something called limits. Okay, you've got to be aware of that. It's like you cannot package like megabytes of libraries and stuff like that. There's a limit, right? But Node.js, Python, Java, C#, Go, and Ruby should pretty much satisfy most of the developers, right? Now, typically, a Lambda function, something is like this, right? There is a handler where all your logic goes in, right? The key thing here is there is this event in a context. Pretty much, event is it's invoked by the Alexa skill set, which when something happens, I mean, there's an intent and you want to kind of handle that. It passes control to the Lambda handler, and then so that's where for example, if you have multiple kind of use cases, you could branch out. For example, if somebody were asking for what is what's my status of my checking account, you could have a branch there. And then if you say what's my what are the interest rates of today, if you ask kind of those are the things, right? The event sources are many, of which one of it is Alexa, right? But as such, we support a lot of events within the AWS world. But when you configure your Alexa skill set, obviously there is an event called Alexa, which you kind of configure it within the Lambda code, which gets where your function gets triggered. Now let's come back to a bit more deeper about what are things that you could look out for, right? The first thing, obviously, when I talk to you about is the handler. But there is a key thing that you've got to understand is, in the serverless paradigm, there is a piece of code within your handler, and then there is something called a pre-section. Okay. So what we recommend is, typically when there are common things that you've got to need to do, right? For example, initialize your logging kind of a thing, or maybe a database connection kind of a thing. More common stuff across invocations, you could do it in the pre-handler part of it. Typically, always the pre-handler gets loaded the first time, and the part of the code that is within your handler always gets invoked every time your request gets called, right? So that's the first step, right? So make sure that you don't stuff the stuff that needs to go in the pre-handler into your handler. Keep it out separately, right? So that has a big impact on the performance of an application, right? Now, the other important thing is within your handler, you also got to make sure that these are basic stuff. I mean, if you've been a developer, I think especially I'm from the Java world. I used to work for Sun long time back. I mean, typically, when you initialize stuff, we always tell them, of course, the garbage collection will kick in, but then make sure that you indicate to the garbage collector that you no longer need that variable, right? So the best thing is set it to null and stuff like that. So these are good housekeeping stuff. So clear out the used variables and things like that, and the other important tip is always import libraries which you really need. Don't use like dart stars and stuff like that. Right? So those are all big no's. And then once you have this handler and the pre-handler stuff, then you could then have the rest of the stuff which helps you to kind of, I would call it as helper functions, to do these things, right? The other important thing is, of course, in terms of environment variables. See, one of the things that we have noticed developers doing it is, how do you handle the transition between different phases, right? So obviously, your skill might transition from, say, a development environment to a UAT to production, right? So obviously, the backends that you talk to should not be the same thing, right? So there could be a development database, there could be a UAT database, and then of course the production, right? So how do you ensure that your skill kind of toggles between these different things? So what we recommend is use environment variables, and using those environment variables, you could kind of switch over between different environments, right? And then the other important aspect, which we have seen a lot of developers trip, is where do you store key things like, especially if you are relying on third-party libraries, there will always be access tokens, there might be database passwords, things like that. So what we recommend is, we have a service called parameter store. So it's one central place where you don't have to hard code anything within your code. Okay? So you could call, the parameter store and get stuff like your database connection string, your passwords and stuff like that. That's the beauty of parameter store. And it's also well integrated with something called a key management service. So, especially for folks who are doing stuff in the financial world, medical, healthcare kind of a thing. You will have to rely, I mean, these are things that kind of trip you, especially if you're going for compliances and stuff like that, because if you have these kind of controls, I mean, you can kind of, show them as proof that you adhere to those things, right? Especially, the questions will, during compliances will be, where do you store your passwords and stuff like that, right? The other thing, now the question here is, once you have this, your Lambda code, and you have all these different, you have written multiple pieces of code. Now, one of the big things asked from our development community was, I'm a developer. I've created, different skills, but some of the things are common, right? So I, as a developer, have developed 5 skills, and pretty much I've kind of reused, or rather, there are some common aspects to it, right? Especially if you are from companies and enterprises and stuff like that. But then there was no way you could kind of share the code across Lambda functions before, right? That was a big challenge, in the sense that especially if you wanted to have a common reusable kind of a layer kind of a thing. That's where we introduced something called Lambda layers. Lambda layers. So Lambda layers essentially is a very nice way, a clean way, a modular way of making sure that any of the common code could be put in the layer. Okay. So as developers, I will request you to, especially if you are going beyond a single Lambda, skill set to multiple skills, and especially if you are deployed, if they are similar, right? So especially what we are seeing is, especially in the enterprise world, when people develop these, skills, there will be some corporate standards, right? For example, the common thing that I could think of is there will be some security kind of layer, there could be other logging kind of a thing, which is common across all the skills. So I will suggest putting all those things in a Lambda layer, right? But be aware that it still does not it doesn't mean that, for example, we have a limit of around 250 MB, where that's the maximum amount of, the size of the Lambda package. It does not mean by using a Lambda layer, I can go beyond that. It does not, but it gives you a more modular way of, segregating your code. So this is how it looks like, right? So, you could have up to around 5 layers per account, AWS account, which we feel is more than enough for a lot of customers. So this is, if you were looking at the previous diagram of this, now I have a more cleaner way of this, right? So I have like a common Lambda layer which could be reused across all my Lambda functions, and that's good, right? So the other important thing is, a lot of developers, when obviously start developing stuff in Lambda, they need to talk to databases, right? Now, it's okay if, there is an option, there is a service within AWS called DynamoDB. It's an NoSQL database. So that kind of, so one of the things that, typically when people talk to database, what's the most common challenge when you're talking like an application that is at scale? What's a common problem that you have to address when you're talking to databases?
Find the query from the Lambda.
Find the query, but what's the real,
connections.
Right? So connections. So connection pool is a big challenge. With serverless databases, that's okay, because it's like it's a REST kind of a call. You don't have to really do a JDBC kind of a thing. But what happens if you are using a relational database kind of a thing, right? So that again was a challenge where you had to really use some kind of like connection pool and do a lot of it's all scary stuff that people were doing it with their own homeschool kind of technologies. So we introduced a service called Rds Proxy. This is still in preview, but especially if you have a real need to talk to a relational database, currently we only support MySQL. But what I'm trying to say is, with this service, you can talk to the Rds Proxy. Rds Proxy handles all the connection pooling and all this lower level stuff for you, right? So for you, Rds Proxy is kind of kind of an interface to the backend. So this is something, right? So another important thing is concept is Lambda. So if you have used Lambda, what are the two things that are important, especially when you are trying to create a function in Lambda? What are the two levers that you have? In the sense that you got two topmost things that you got to find out.
Scalability.
Scalability, but then does it mean that you have infinite kind of
memory and execution?
Memory and execution, right? So you can. The only thing that is under your control is memory. That's the lever that you have. You can start off from around 128 MB. You can go up around 3 GB, right? And then the execution time cannot exceed more than 15 minutes, right? So with this kind of limitation, what we're saying is don't stuff a lot of things within your Lambda code, okay? Especially if you got to work in 15 minutes is way too much for an Alexa skill, but I'm saying it's still there if you don't really need to use it. But what we're saying is, don't stuff a lot of things within your Lambda code. Make sure you do stuff. What we're saying is, don't do things like get a lot of data and then I iterate to the data and then select only that part which is required and then do the stuff. Don't do things around which can be done elsewhere, right? So one common thing is, for example, there is a query filter in RDS database. Then similarly, if you need to get data from our S3 kind of an object store, there's a concept called an S3 select, so that you only get stuff that is relevant for you, right? Because you are working within this limit of 3 GB and 15 minutes kind of a thing, right? So make sure that you don't do a lot of these kind of things which is not relevant to your business logic. Make sure you kind of offload them, right? Now, so just to give a kind of a brief recap, use Lambda layers and concise logic. Don't stuff a lot of things, and use things like proxy and stuff like that, especially if you're got a top-end, back-end kind of databases, right? Now coming back to the execution time, right? Now, when you run stuff in Lambda, this is what happens, okay? So let's assume that your Lambda function was never invoked. So what happens the first time is the compute substrate once it gets a request, it then initializes something called a container, and then within the container your function gets loaded, right? So there is this big problem called a cold start, which happens if your function has never been called or if your function has not been called at all for a long time. Now obviously we don't keep your stuff running all the time, right? Because even we have a finite amount of compute power. So we kind of passivate your stuff, and then when somebody calls, you got to reload them again, right? So this is called a cold start. Typically, this is not very evident for a lot of people, but then if you are in some kind of a skills which is like real-time kind of a thing, sometimes the first invocation takes a few seconds versus the subsequent invocations which are always in the order of milliseconds, right? So there is, this was a known problem for a long time. People had different kinds of solutions, homegrown solutions. Some people would kind of create this kind of jobs which would pin the skills, sometimes so that it always never gets passivation, right? So all these were kind of homegrown solutions, but then we are having some solutions for this, which I'll come to in the next few slides. The first thing is, you got to understand also sometimes, how do you know how your code is performing? We have a service called X-ray, which literally looks and gives you some kind of information on how much time was spent within your code and stuff like that. So X-ray is a nice way for you to profile your applications. So, so rather than kind of guessing how much time it took in each of these functions, you could use X-rays to kind of generate this nice graph, and you will get a kind of a nice pictorial way of representation where it can tell where the most time was spent, right? So and then you could kind of debug it. So this is a nice way, for example, in this graph you can easily see that the dwell time or rather the querying for S3 took a lot of time, right? So here it took something like 6,062 milliseconds. That's obviously the place where you need to look at optimizing things, right? So that's a nice way to debug stuff. Now, the other important thing, as we said, as the gentleman said, there are two levers to control a Lambda function. The first one is obviously the memory, and second is the time, right? Now, the thing that you need to understand, especially if you are new to Lambda, is even though we expose memory as your lever, we also give a percentage of CPU and network based on this memory, right? So that means if you have allocated 128 MB of memory for a Lambda function versus somebody who's allocated 256 MB, they will get proportionately more CPU power allocated to them for 256 versus 128, right? Now let's come back to that with a real world example. So this is a small test that we did where we allocated different amounts of memory for the same Lambda function, which is doing some small stuff. It was calculating some prime numbers less than 1 million, and it was iterating 1,000 times, right? So look at this for a second. As you can see, obviously the response time improves as your memory goes up, and the last part of it is obviously the price you pay when you allocate so much memory for this Lambda function, right? Now, the green ones are the best time, and this kind of is obvious, right? So if you think that you could save money by allocating lesser memory, you're wrong, because it takes more time to process the same thing, and you're paying more, right? Now the difference between 128 MB and 1024 is, even though it's yellow compared to green there, it's only that much, right? But you are shaving off 10 seconds from your processing time, right? So that's a big saving. So make sure that you profile your application and allocate the right amount of memory. It does not mean that everyone should go ahead and allocate 3 GB, right? It is not. But what I'm trying to say is, when you use things like X-ray and stuff like that, you can always find out what is the optimum amount of memory that you kind of allocate. And more memory does not mean that you're paying more. It means that it's optimum for whatever the Lambda function requires. The other important thing is, there are cases, also about how much CPU gets allocated to your Lambda function. This is some kind of a thumb rule that you could see. Anything less than 1.8 GB, you get a 1 core. Anything more than 1.8 GB, you get a multi-core kind of a thing. But for you to make use of a multi-core kind of a thing, your code also should be kind of multi-core friendly, right? So it's important that you have that. It does not mean that more CPU is better, but especially for things which do some kind of which take care of, especially if they are using some multi-processing kind of libraries, obviously this helps, right? The other thing which is very you don't have to do anything, but which we did. Remember the cold start thing that I was talking to you about? One of the important things, that was causing this cold start was when you are running this Lambda function within our virtual private cloud, what we call as a VPC. One of the biggest factors that was causing this cold start time was allocating something called an elastic network interface. Basically an IP address for your Lambda, right? That used to take a lot of time, but then we have done a lot of backend kind of, especially we are using something called a firecracker. It's a micro VM kind of technology that has definitely reduced a lot of this cold start, and typically for things like which are taking like 14 plus seconds during the cold start, not always, only during the cold start, the first invocation sometimes was taking like 40 seconds. That without you having to do anything, now it takes around 933 milliseconds, right? Because we have changed our hypervisor kind of a technology to use something called firecracker. This is very transparent. You don't have to do anything. But what I'm saying is, using the latest stuff that's been rolled out to all AWS regions, right? So, including Bombay. Coming back to events, right? Now, some of these are generic Lambda suggestions. There is, important thing for you to know is Lambda can be invoked both synchronously as well as asynchronously, right? So that means you can do stuff which can be offloaded, right? For example, I can think of, especially if you're relying on a slower third-party kind of backend, you can pass it off as an async kind of a thing versus waiting for those third-party things to come back. Because then the overall time it takes for a Lambda to get processed becomes slow, right? So that's one. And there are multiple ways in which Lambda itself could be invoked, but this is, more from a generic Lambda session. But the most important thing for you is when you create using a synchronous kind of a model, especially your backend breaks, the question that happens is how do you do things like retry and stuff like that. So it's important, what we suggest is going for some kind of a async kind of a thing, so that you just fire off that request and come back saying that, for example, especially if you are doing things like where you take orders and stuff like that, you can say the order was submitted, and then the order could be placed in like a message queue kind of a thing, and then you come back. It's not rather than waiting for a third party kind of a service that for it to acknowledge that the order has been placed and stuff like that. So try to make use of async kind of an event, especially in today's world where people have a very kind of a small time for latency and things like that. Nobody likes waiting for stuff, right? So this is an important thing that you kind of got to think through, whether you want to do an async way of doing stuff, or do you want to wait for. There are some use cases where synchronous still makes sense, especially if this service B is within your span of control, right? In that case, obviously, you could use this while synchronous kind of a mechanism, but async definitely works for a lot of cases where you don't have control over service B there, right? So that way, there are a lot of mechanisms in how you could do this kind of an async way. Let me just. So these are a few ways in which you could do stuff in an async manner. One, of course, is something called an SNS. We have a simple notification service, or we could use a queue for posting your message, and so that somewhere down the line somebody else picks up the message and processes it. And then we have a new service called Eventbridge. So what Eventbridge does is, in this case, your Lambda posts a message. So you have all these other functions which can then take that message and process it, right? So this is like a bus, an event bus that could kind of be a glue between other stuff and Lambda, right? So try to make use of something like an event bus. So Eventbridge has not just AWS, we also have integrated with a lot of other third-party providers. For example, sending email, we have integrations with other third-party email providers. So that means, for example, this could be like a third-party email provider where you just sends that order confirmation, right? You dump it in Eventbridge, and then this third-party service that you have integrated with, that could take that message and send an email to your customers saying that order has been fulfilled. You don't have to call that third-party directly. I hope you're getting it, right? So this is what we popularly call within the developer world as loose coupling versus tight coupling, right? So it's a very important architecture principle that you got to adopt. So don't ever get into a tight coupling situation. Make sure that you use either an Eventbridge, or maybe it could be something else like an SQS or an SNS. Now coming back to a bit more stuff. One of the things that a lot of things that you keep hearing in the press is about security issues, right? So people keep stuff within S3 buckets, and then it gets exposed to the world, right? So all this, simple thing, right? I don't want you to try this. I don't want you to ever try this. So there is this concept of access key and secret key within the AWS world, where if you need to invoke the AWS SDK, you got to set this access key and secret key, and then you could call a command and interface, right? So if you we have had several customers who have done this by mistake, and obviously they don't do it by design. So a new developer, by accident, hard codes this access key and secret key within their code, and then pushes that code to GitHub. The next 2 seconds, there are all these bots out there, they're constantly scanning GitHub for all this secret key and access key. Before you know it, somebody uses this secret key and access key and launches some large instances, runs some Bitcoin stuff, and then, all they need is some compute power. If they get it for 10 seconds or 1 minute or 5 minutes before you realize, you will have done this stuff, they've made some money in that and gone. Right? So, where I'm leading to is, you run this stuff in Lambda, make sure you give it the right security kind of credentials, right? There are 2 aspects to it. One is called a function policy. That means you're kind of tightening who can invoke a Lambda function, right? Not everyone. In this case, it's only the Alexa. But generally, when you develop stuff, make sure that you give only who can do it. And then, of course, what can your Lambda do, right? Never ever give a star as an IAM kind of a policy. IAM is our identity and access management. So always kind of, if your Lambda function needs to talk to DynamoDB, make sure that you kind of restrict that policy to only talk DynamoDB. Alright, even if by accident a malicious code gets into your code, it should not invoke other stuff. And even within that, you can go to the next level of specifying only a particular database, and then you can reduce the scope even for the sake that you can only do read stuff, write stuff, and things like that. So Lambda permissions is very important. You kind of restrict it, make sure that you don't come in the Twitter or next is headline, especially if you are doing some real world stuff, right? Don't expose stuff and things like that. The other important thing is Lambda is still pretty much a developer kind of a thing where there's a lot of toolings around, especially if you are coming from other OS where you had all these nice rapid application development kind of environments. But we are slowly making sure that we make sure that the initial effort of developers to start using Lambda is easier. We have introduced something called a serverless application model. So it's a more templatized way of creating Lambda functions and also all the stuff that I was talking to you about, right? So rather than you going there, physically uploading a code, setting all these execution policies and things like that, we have created something called a SAM. So you could create something like this kind of a template where you kind of specify what you want to do, right? So in this case, I'm saying this is my Lambda function. It's running as a Node.js kind of an application. And I'm saying that if you look at it, right, so if it's giving you, who can invoke it, what's URLs and stuff like that. And most importantly, I'm also saying that, it can do only a DynamoDB read. I'm not giving anything else. Whereas if you were to do this yourself, manually you'll have to go into multiple places and configure all this, right? So SAM is a nice way of doing stuff, and especially from the security side of things, we have made it even more simpler by creating a lot of this commonly used security things. We have put it in on GitHub. We have created some 50 plus predefined policies, common stuff which a lot of companies use, right? Especially if you are, rather than you creating your own policies, you can go to this GitHub and use that particular policy, right? So for example, I'm talking about something like this DynamoDB read policy and database read policies and stuff like that, right? So just to kind of recap, right? More memory gives you a proportionate amount of CPU and I/O, and make sure you kind of profile your application using things like an X-ray or something else, so that you have the right amount of memory to be allocated to your Lambda function, right? And then of course, the most important thing is try to think in an asynchronous manner rather than like a time coupling kind of a thing, especially if you are, required to talk to other third-party services where you don't have control to. Right? Now last but not the least, I was telling you so far you do not have too much control about, especially in terms of, if you wanted to, if you knew, for example, that, especially, in the e-commerce, not exactly e-commerce, I would say in the enterprise kind of skills, where, you have something like 100,000 customers, and that you have like, at any given point of time, at peak, I have like 500 concurrent users, right? How do I now make sure that, the response time of Lambda was always uniform across all these 500 concurrent users? Earlier, there was no way you could, give this kind of a, I wouldn't call it as SLA, but at least a similar kind of experience for all these people, right? We heard you, and we came up with something called a provision concurrency. So that means you could specify some kind of a concurrency based on your user pattern, right? So you could, for example, specify that I mean my concurrency could be like 20 or 100 or something like that, right? So where it comes into picture is especially the last part, right? So usually in the 95th, 99th, 98th kind of percentile is where you will see some things that are related to cold starts and stuff like that, right? So that is the part which a provision concurrency is trying to address here, right? If you were to give it this concurrency, if you see the red stuff, the response time is uniform for all 100%, right? It's not going to like the blue line where I do not have this option of provision concurrency, right? For example, what it's saying is for certain users, not always, right? Anything up to 90th percentile, I have a very good performance. But for certain users, I could, it could take something like 2,000 milliseconds and stuff like that. I want to avoid that kind of a thing, right? So for that, you have this concept of provision concurrency that we introduced last year. And also similar to memory, if you have a situation where you are guaranteed to have so much amount of concurrent users, setting this will not be very expensive. It kind of pays for you in the long term, right? Similar to the memory kind of example that I told you about. It kind of addresses one of the common complaints people had about certain users facing a long time for response time and stuff like that. So this is in a nutshell very rapid kind of things that you could do with Lambda. So in a nutshell, these are a few things that I talked to you about. I'll leave you pause for like 5 seconds so that you kind of absorb it. So first thing is, of course, especially your side of things, where you write your application logic. The second part is the other kind of levers that you have around the Lambda itself, setting memory and async and those kind of things. The last part is basically the Lambda service part, where you could use things like provision concurrency and stuff like that, right? So, so these are, I think, what I typically call as day 2 challenges, right? So you got your stuff out, and now it's running. People have started using it. How do you optimize it, right? So, I mean, these things might seem sometimes like an overkill for you, but these are stuff that will help you cross that, becoming, for example, where people start talking about a lot of people starting to use your skills, right? Especially, I'm talking about enterprise kind of scenarios where, where people are using it for day-to-day kind of a thing, right? So that's where you kind of got to do all these things. A few resources. One, of course, is we have an online workshop called which AWS has created called alexaworkshop.com. It has got 2 nice examples. One for a smart home kind of skills, and one is a smaller kind of skill. But it kind of walks you through a lot of things that I talked to you about. And then we have a GitHub repo where you could download a lot of sample code and stuff like that. And finally, there is also a certification. It's nothing more, it's more like a bragging rights, right? So there is a certified skill builder. It's only, related to that part where you build skills. It's not obviously, you're not an Alexa certified, right? It's the Alexa skill builder certified, right? There is a free exam readiness training that is available for you to take, right? So, I'm completely out of time. I think you guys are also late for lunch. You could always have this conversation. I'm on LinkedIn and GitHub, GitHub of course, and LinkedIn and Twitter. Please do drop in every year. We could continue with this conversation. And of course, make sure that you follow some of these best practices if not all.